Okay, we've got some examples here where we have to add some fractions, but the fractions have got algebra in them. So I'm going to show you some numerical ones just to remind you of how we add fractions with numbers. So if we were adding something like 2/3 to 3/4, okay, on this one, 3 and 4 have no common factors, so my common denominator has to be 12, so each one is going to be something over 12. So this is the case where I actually have to multiply these together to get the common denominator. So how do I do it? Well, this is going to be a fraction over 12. What's happened to the 3? The 3 has been multiplied by 4. So on the top I need to do the 2 times the 4. And then on this one here, so that's 8/12 is the same as 2/3. And then 3/4 is the same as well. The 4 has been multiplied by the 3. So on the top I need 3 times 3. And 3/4 is the same as 9/12. So 8/12 plus 9/12. The point of doing that is if I've got 12ths and then more 12ths, I can add them together and get 17/12. Or 1 and 5/12 if you really want. But that's how we do it with numbers. Okay, so with fractions, we need to do the same thing. So the first thing to ask yourself is, do I have to go as far as multiplying these two denominators together like I did here in order to get the common denominator? And the answer in the first case is yes, I do. So this is going to be something over 2x times brackets x plus 3 plus something else over 2x brackets x plus 3. So the first thing to do is to decide what your common denominator is. Then you look at each fraction individually and say, okay, so I've multiplied the bottom of this by something, and we can see the 2x is still the same. The new factor is x plus 3. So I've multiplied the bottom of this. Okay, I've done a times x plus 3 here. So if I'm doing that on the bottom, then this 3x plus 2, which is really a bracket of 3x plus 2 on the top, has got to have been multiplied by something as well. And it's got to be multiplied by the same times brackets x plus 3 that I did on the bottom. Okay, so that's the principle. I'm not going to draw these arrows on every time, but that's what we're looking for. What's the bottom been multiplied by, and therefore what do I need to multiply the top by, and it needs to be the same. And you could see that this, if I simplify again, I'd cancel the x plus 3's and it would turn back into that, okay? But the advantage of this is that once I've done this to both fractions, I'm going to be able to add them because they will then have the same denominator, just as putting these over 12 was a good plan. Okay, so the second one, there's a 2x plus 1, 2x minus 1, I should say, and that's really a bracket of 2x minus 1. What have I multiplied the bottom by? Well, this bracket of x plus 3 is still there as a bracket of x plus 3. This is the new bit, the 2 times 2x, so I need to multiply by 2x. Okay, so I've now got a common denominator, so I can just add the top bits together. So I can put 2x brackets x plus 3 on the bottom. I could even multiply that out if I wanted to, but I'm not sure I do want to. But on the top, okay, I didn't leave this as 2 times 4 plus 3 times 3. I actually multiplied them. And here I think multiplying out is going to be the right thing to do. Okay, so the idea is I'm going to find out whatever this is, and it's going to go here. And I'm going to find out whatever this is, and it's going to go here. And then I'm probably going to need to do one more line of simplifying. So this is really a grid, isn't it? 3x plus 2 times x plus 3 gives me 3x squared, 2x, 9x, and 6. That's a bit untidy, but I've used up all my scribble space. Very careless of me. So I've got 3x squared, 2x plus 9x is plus 11x, okay, plus 6, and this I can expand without a grid. I've got plus 4x squared minus 2x, and that is all going to simplify. The x squareds, I'm going to have 7x squared. I'm going to have the x's, 9x plus 9x plus 6, all over 2x brackets x plus 3. Okay, now there's just a possibility sometimes this will simplify. So does the top factorize nicely? B squared minus 4ac, no it doesn't. So I'm going to leave it like that. If there may be a reason why you'd want to go further and look for for other opportunities to factorize or simplify further, but that's fine. We've done what we wanted to. We've turned an addition of two fractions into a single fraction. Now the single fraction we end up with is nastier than the two fractions we were adding, but sometimes that's the right way to go. If this was equal to something else, okay, then I could start multiplying by the bottom and turn it into an equation, so you know, it wouldn't be a bad thing to have necessarily. Okay, anyhow, I'll shut up about that. Onwards and upwards with these other things. So we've seen the first thing to do is to get our common denominator. Now on the last one I had to multiply these two expressions on the bottom to get the common denominator. But here that would be a foolish thing to do. This is like adding 2/3 to 4/9. Okay, you do not want to go into 27ths on this, okay, because 3 is a factor of 9. In fact, 9 is 3 squared. So you'd leave the 4/9 completely alone and you'd express the 2/3 as something over 9. Well, you've multiplied the bottom by 3, so it's going to be 2 times 3. It's going to be 6/9, and you take it from there. So that's what we do here, okay. I've got a bracket squared and just that bracket on itself, so this denominator will do for both. So I'm going to have something over x plus 2 squared plus something else over x plus 2 squared. Sorry, it's minus, isn't it? Okay. Minus what? Well, this fraction I don't need to change. Okay, this is going to be minus x plus 1. And you do need to put that in a bracket. That's going to be important later. But this one here, there was an x on the top. What's happened to the bottom? Well, it was x plus 2. It's now x plus 2 squared. So I've multiplied by an extra factor of x plus 2. So I need to do the same on the top. So the top of that one is x brackets x plus 2. The bottom is x plus 2 squared. This is x minus 1 in a bracket. Why does it need to be in a bracket? Well, when I put everything over x plus 2 squared, okay, I'm going to be multiplying this out, so this is x squared plus 2x. Okay, right, well, if I were to now write minus x plus 1 without the bracket, it would be wrong, okay, because this minus in front of the bracket changes that plus 1 into a minus 1. So that's why the bracket was essential at this stage. I've now removed that bracket, I've taken account of the minus sign, so I'm correct here. But I haven't quite finished, because this does simplify to x squared plus, it's just going to be plus x minus 1 over x plus 2 squared, and I could look for opportunities to factorize and simplify, but I can't be bothered. I don't think it does. Okay, I think that's about as good as you're going to get on that one. Now this last one, okay, this one is the simplest of all, but in a way it looks confusing because this x doesn't even look like a fraction. Okay, this is like how what you'd have to do if you did 2 plus 4/3. You'd have to write the 2 as something over 3. So if you've only got one denominator, that's your common denominator. The 4/3 here, sorry, 2 plus 4/3, if I'm doing that, the common denominator is the 3. So the 4/3 isn't going to change, and I have to put the 2 over the 3. So this is a 2. This 2 is 2 over 1. So we can write that as a fraction before we start. So the bottom, the 1 has changed into a 3. So I'm multiplying by 3. It's 2 times 3 over 3. 2 times 3 over 3, 6 over 3 is indeed 2. So it's true. Okay, but when I've written it like this, I've got 6/3 plus 4/3. I can add them together and get 10/3. So that's what you do with numbers. We need to do something similar with the algebra. So this is an x over 1, if you like. So that x is x over 1, but I want to make it something over the denominator. What denominator? Well, it's x minus 3. This second bracket, this second fraction, it's not going to change. It's x squared over x minus 3. Happy with that. So I need this to have an x minus 3 on the bottom, but x is really just x over 1. So what do I need on the top? Well, I've got an x, but I've multiplied the bottom by x minus 3, so I need an x minus 3 on the top. And if you look at this term, you can see I've got a bracket of x minus 3 on the bottom. It would cancel the x minus 3 on the top. This would cancel down to x, which is what I want it to equal. So you can now see this is a valid way of rewriting my x in a form that can be added to this other fraction. So the denominator is x minus 3. This multiplies out to x squared minus 3x. I've got a plus x squared, so I'm going to end up with 2x squared minus 3x over x minus 3, which I suppose I could factorize to x brackets 2x minus 3 over x minus 3 if I wanted to, because that simplifies so easily. And we're done. So that page there is how you cope when you have to add algebraic fractions, Okay, but the exciting bit is what we do next. Okay, sometimes we quite like this single fraction, but sometimes you can see that all of the things I started with, okay, in some sense look simpler than what I ended up with. So when we do this next page here, wherever we get to it, okay, I think it is your next page, it's just a bit mucked up here. Yeah, okay, this page should be next for you. All right, on this stuff, this lovely stuff called partial fractions, we're putting that into reverse gear, okay? So that will be fun.